G'day, my name's Luke James Stevens, and I just thought I'd do a little bit of a development diary for Dancing Fingers. So first off, what is Dancing Fingers? Dancing Fingers is the concept of using all of the patterns of your fingers. From looking it up on the web, I found out that it is also called finger binary, one of the ways to label it. Essentially, it's all the different combinations of your fingers. So you may have just that finger going down, which could represent 1. This finger could represent 2. So them together represent 3. It's a bit hard to keep that one up. So, and you can cycle all the way through. This 5 fingers produces 31 numbers. So you can count to 31 just using your hand. So how can that be used? That can be used through many different means, counting numbers for instance, but I was interested in taking it to the computer and taking it to the trackpad. And the trackpad is a glass surface which picks up any touches on it, and through those touches I detected the fingers, and then from that you could calculate the number, so right from 1 up to 31. And then I assigned the alphabet to it, and space, and delete as well. So you essentially can produce a functioning keyboard, a one-handed functioning keyboard using the trackpad. So that's one way you can use it. So why do this at all? Well, first it began out of curiosity. It was just staring at my fingers thinking, surely you can count higher than just what's on your hand. And from that foundation you can create some interesting things. And what I discovered over time is it's actually faster for me to type numbers using my hand after about 2 weeks training than using 2 hands on a keyboard, on a computer keyboard. So so much so that if I'm speaking the fastest that I can speak, like 1 to 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like my fastest attempt at that can be matched with the speed of my typing one-handed using what I'm calling dancing fingers or finger binary. And that was surprising to me because I've spent so many years, more than 20, 25 years typing on a keyboard. So yeah, so that's sort of the introduction of dancing hands. And now I'll go into some more technical stuff in terms of challenges. So one of the challenges for me developing this, one of the biggest challenges, was I could count to 15 fine, which is for 4 fingers. But getting to 15 turned out to be quite an elusive challenge, and it revealed itself after a little bit of playing around. Firstly, this biggest challenge was very simple to fix, actually. Very simple to fix. It's just finding out that it exists, that the solution exists, and identifying the problem. So not being able to count above 15, or doing so, was very inaccurate. Like, you'd maybe get 5 misfires of trying to type a letter before you got the letter you wanted, which is not useful when you're using it as a keyboard interface. And you know that your fingers are going down in the right sequence, but it's just not triggering correctly. So the way I worked out how to identify the problem was logging out the information, all the touch points, and the touch points have states. So if you tap down with one finger, it will register as, you know, it's begun, it's in a state of stationary, or it's ending. And what was happening was it was going into a stationary state shortly after, which was fine because I could still track it. I was like, okay, the finger is in this position on this trackpad, and should really have the trackpad in front of me so I can sort of demonstrate that. In fact, I will. I'll be back in 1 second. Okay, so here we have it, the trackpad. Now I'm just going to recall my train of thought. So this is the trackpad, this is counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2 to 3 to 4 to 5 to 6 to 7, 28 to 9, 30, 31. 31 is all of the fingers down. So touching down, I discovered that it was going into stationary state, and then a few seconds after that it would become in sort of a, well, it disappeared essentially. The tracking information ceased to exist in memory, so I didn't know what was triggering that because it hadn't ended per se. So I was very baffled. And what it turned out was happening, after logging that it was disappearing, then I could say, okay, it's disappearing. That's obviously a problem. It would only come back when it's no, it wouldn't come back at all. Sorry. So how do you find a solution for something that's just disappearing? And doing some searching into the documentation of this trackpad and of the macOS framework which interfaces with this, it turned out there is a setting for the driver, and I explored the documentation on that setting, and it turns out that the fingers, say I put 4 fingers down, so I'm not, my root finger's not down, and it would consider those 4 touches, and it would then say that this one finger, say to the left, is in a resting state because you've touched it. It's not really gonna do much else. Like, it thinks that the gesture's complete, and this can happen within milliseconds. So we're talking like, you know, maybe it's 1 to 200 milliseconds. So it's within that time frame that's happening, because that's how fast you type between the letters. Well, my average typing rate was around 250 milliseconds. So the problem was happening, you know, within that time frame, because I was going through the sequence of letters. The sequence of numbers or letters, and it was erroring out. So, and it turns out that it considers it's a gesture that's finished. So the driver actually has that feature. So the driver doesn't pass on the information of the tracking information of where the fingers are. So simply enabling, I want to listen to those events in the Boolean value, you're able to get those tracking information. And from that point onwards, it was much smoother to be able to type, because the tracking information didn't disappear when I was expecting it to be there, when I was trying to reference it in the code. So that was probably one of the most elusive problems with this project so far. And there's many other challenges which I'm still facing, which I may go into in other videos if I think it's worth doing. Maybe just for myself to log, or for others to learn upon and maybe think about how to solve problems or how to approach things. I will explain one more. Well, one curious thing is working with dancing fingers is finding the letter is not intuitive as a beginner. So over time, for instance, using a keyboard, you will find that as a beginner, it's pretty easy. You'll be slow, but it's intuitive because you want the letter A. The letter A is there. It's written on the key. The trackpad has nothing, so that causes a few issues. So whilst practicing, one of the things that I implemented to try and mitigate some of that, I guess, training friction. I'm not sure what to call that. Things in the way of you trying to learn this thing. So to do that, I vocalized what was being typed. So 1, 2, 3, 4. So I would get the synthesizer, which is the built-in voice of Siri in this case on the Mac, to vocalize those numbers or letters. So when you're typing, you get a verbal feedback, which helps your brain, helps the neurons create the logical connection that, okay, this pattern is A, or this pattern is 3, for instance. So that's one way to do it. And another way, for visualization, I created a challenge for myself to type a full sentence. So the full sentence that I first put in was, "Hello, my name is Luke." And the hello part was pretty simple to type because it's those letters revolve around the first 4 fingers. So H being this finger here and this finger here. So H, E being these 3, and L being these 3, and actually O was these 2 end ones. And the brain maps onto that one pretty easily. But when you get into like M and Y, they're a bit awkward because I think it's... M's actually not too bad. M's just those 4. But Y is those ones minus that fella, I'm pretty sure. So it's a bit awkward to type. For me, it's harder to remember that one. For other people, maybe it's different. So there's challenges in that, and one of the ways that I tried to help that for myself and for the people who still have some vision is creating a vector graphic of the hand. So it is an outline of the hand, and it has the circle radius. These circles attached to the end points of the fingers. So the circle exists or it doesn't. So the circle exists for your end fingers, this one and this one, and that creates the letter O. So the letter O. So what that means is visually you get a vector graphic with a circle here and a circle here, which indicates to you which fingers you need down to be able to type that letter. And I had the whole alphabet done up there. So you've got all the way from A to Z with space and delete. And it highlights, so the whole hand changes color and has the letter written there. So it highlights it, and that's one way that I've been trying to mitigate that friction to learning the patterns of typing. So that's 2 of the challenges that I've faced so far, and there are many more that I'm still working on. I guess an unsolved one, which I have a path to solving. I won't go into the path of solving this one, because I'd like people to think for themselves and see what solutions they would come up. I'd rather give solutions that are fully baked. But the problem exists, so I'll talk about that problem. So the problem is just trying to think the best way to explain it. So yeah, so the problem is that when you're typing, to initially get the positions of the fingers so that I can reference it, because I don't know that I don't know anything when the trackpad's first put on. So how do you know where all the fingers are? So the first thing to do is put the fingers down in the sequence that you want. So this is finger 1, finger 2, finger 3, finger 4, finger 5. Now from that point onwards, I'm using the XY coordinates of all of these finger positions as the referencing points. So if I take all my fingers off and put that one down, it has to land pretty close to where I initially put it. So one of the issues is when you're dancing away with your hand is you get sort of hand creep, and this finger can creep into the one next to it or to the right of it, or the whole thing can shift to the right, to the left, and that is one of the problems that I'm working on right now, and I have a pretty clear solution in my mind, so I'm pursuing that, and yeah, we'll see what that leads to, but pretty happy because the information that I'm getting now is it's going to be fun. It's going to be good. So I think it's going to be quite a good challenge to work on, because it's probably going to create multiple solutions. So for instance, I don't really want to go into solution, but I will go into a different solution that I've created, which is I was manually writing down the times for the total time for being able to type from A to Z, for instance. Or 1 to 15 takes 3.8 seconds to do. So counting from 1 to 15 takes 3.8 seconds to go through there, the quickest that you can do. So I was logging that information to the console, I think it was, to get the final time, and then I was averaging it out for 1 to 15 to get the time between characters. But that's not accurate per se per letter, because going from A to B may be quicker than going from C to D, for instance. So one of the curious things is I'm finding patterns in the data, because I've started to log the time that you did this, for instance, and the time that you did that. So you can find like a progression of time from 1 to 15 from A to Z. So you're able to work out the exact milliseconds that it takes between typing the character A and the character B. And it's good information to have, because then you can work out the fingers that are the most problematic. So you can find out like what's the slowest for the body to type, and when you get to the phase that I'm at the moment, which is typing entire sentences, you find that at least for me at the beginning, there is struggle for the mind to comprehend a certain letter. So Y, for instance, it's taking me a while to train my brain that's why. So a useful thing to do would be to track that over time. So I'm logging all this information to the to file to on disk. So over time, all of the information is there for one to be able to dig through that and discern the response time of the letter over time. So maybe going from A to Z took you, let's say 253 milliseconds, and then over the time it's gone down to 40 milliseconds. So you can see that you've improved typing the letter A when you're going from A to B. So there could be all sorts of curious things that are discovered over time. For instance, maybe certain words that have the same characters but are in a different pattern, I don't know, I can't think of one right now, but if you wrote the word hello and then you wrote the word hello backwards, maybe it's quicker to write it backwards than it is forwards. I'm not sure, but you could discern that from the data. So yeah, there's some of the challenges and problems and a few solutions there that this project has demanded to be created. So not sure if this is going to be a useful video or not, but I hope it is to somebody, and maybe it's just a historical interest for me to look back and look at some of the problems, because some of the finer details are maybe sometimes lost in the noise of working on the bigger project. Probably not for the hard problems though, because I don't think I'll forget the hard problems, because they cause the most pain, so your brain is very good at remembering pain. So there you go. Yeah, thanks very much for watching this, and wish you all the best in whatever endeavors that you're pursuing in creativity. So have a good one.